Okay, so let's get to talk about the circle. In this lesson, we'll just talk about the introduction to a circle, then we'll talk more about the geometry of a circle in the later videos. First, let's talk about the lines that can be drawn inside a circle. Before we even start talking about the lines inside a circle, let's talk about the distance right round the circle, and we call this the circumference. So the perimeter or the entire distance right round the circle is called the circumference. This is the line that you're seeing in black. Then next to the circumference, we have the chord. So by definition, you see that the chord is any line that is drawn inside the circle with both ends touching the circumference. And from that definition, you can also notice that the diameter is doing just like that. Both ends of the diameter are touching the circumference. But the unique feature now of a diameter is that it is passing through the center. So a diameter is nothing but just a chord that passes through the center. In actual fact, if somebody comes through to say that a diameter is a chord, that will be a fact. But for the reasons that it passes through the center and it is the longest chord that can be drawn inside the circle, we then have to give it a special name called the diameter. So the diameter basically splits the circle into two equal halves. And we call these semicircles. Then next to diameter, we have the radius. And the radius is just a line that is drawn from the center of the circle to the circumference. By this, you can notice that the radius is always half of the diameter. That is a point that you have to note for all the next sessions that we are going to be doing. The radius is always half of the diameter. Moving on, we have a line that is called a tangent. A tangent now does not cut the circle, but it just touches the circumference of the circle. So we're seeing a line there that is being drawn to just touch the bottom part of our circle, and we call that our tangent. There is a property that you're supposed to be mastering that goes with the radius and the tangent. The radius is always perpendicular to the tangent, meaning to say that whenever the radius meets the tangent, they form a right angle. So we have a right angle here on the right side, and we also have a right angle on the left side. So you are supposed to be noting this point again. The radius is always perpendicular to the tangent. Now, let's talk about an arc. The circumference itself is made up of small arcs. So an arc is just a small section of the circumference, right? So combining all the small arcs that are on the circumference, we form the whole perimeter of the circle. So an arc is just a line that is on the circumference of the circle, right? That is the line that you're seeing in red there. Let's talk again about a segment. We mentioned about a chord before. So a chord is a line that is drawn inside the circle with its both ends touching the circumference, right? So the chord will result in the formation of segments. We have the whole segment that is on the upper part of the chord and a segment that is on the lower part of the segment. So to differentiate these two, we will call the bigger segment the major segment, and the smaller segment we will call it the minor segment, right? So as you're seeing in this diagram, the blue section is depicting a segment, a minor segment to be precise, right? Let's also talk about a sector. A sector is an area, is a small portion of the circle that is enhoused or that is covered by two radius lines and an arc. You can see the portion that is labeled in green there. We have an arc and we have this radius and this radius, and this whole portion is the one that is being called a sector. So in actual fact, this is called a minor sector, and the whole section that is behind it is also a sector. Why? Because it's fitting to the definition. We have this whole arc covering from this point to this point, right? We also have this radius and this radius contributing to the formation of this sector. Whenever there are two radius in a circle, we will always see a minor sector and a major sector, right? This is it all on one page. We have the circumference of the circle, which is the distance right round the circle. We have the arc, which is a small portion of the circumference. We have a chord, which is a line that is drawn inside the circle with its both ends touching the circumference. From there, we have the diameter, which is a straight line that is drawn passing through the center of the circle. Also have a tangent, and the tangent is meeting the diameter, forming a right angle there. We have the segment there. In green, we have the sectant. The sectant now is a line that is more of a chord, but its ends are cutting through the circle, right? The line is cutting through the circle. So a sectant is just a chord that cuts through the circle. Their ends are not only getting to the circumference, but they are passing through the circumference. So it cuts the circle on two distinct points. That's a sectant for you. We also have the radius there in blue from the center to the circumference. And we also have a sector that is in yellow. Moving a little bit to talk about the perimeter and the area of a circle, we are going to be using the diameter or the radius or the relationship between the radius and the diameter to find the area and the perimeter of a circle, right? To find the perimeter or the circumference of a circle, we just multiply pi by diameter. And in most cases, pi is presented as 22/7 or 3.1. Right? So, we are saying that the circumference of a circle or the distance right around the circle is obtained by multiplying pi and the diameter. Right? If we're not given the diameter and we are given the radius, we just have to multiply the radius by 2 first, then we multiply by pi. Simple, right? Then, when we are calculating the area of a circle, we are first supposed to be multiplying the radius by itself 2 times, then we multiply by pi. So the area of a circle goes by pi multiplied by the radius squared. Simple, right? In the event that you're not given the radius and you're given the diameter, you're first supposed to divide the diameter by 2 so as to obtain the radius. Then you multiply or raise the radius to the power of 2, then multiply by the pi. Simple, right? This is an example with perimeter and area of a circle. Suppose that we're given a circle with the radius as 14 centimeters. To calculate the perimeter of a circle, we are supposed to say pi multiplied by the diameter. But in this case, we're not given the diameter, we are given the radius. So we will multiply the radius by 2 so as to obtain the diameter first. Then we multiply by pi. Assuming that our value of pi is 22/7, we're going to be saying 22/7 multiplied by 14 times 2. 7 into 14, that's 2, leaving us with 22 times 2 times 2, giving us a 48, giving us an 88 at the end of the day. Since our radius is in centimeters, our perimeter also is going to be in centimeters. Simple, right? Moving on to area. Area is supposed to be pi multiplied by the radius squared. Lucky for us, we are already given the radius. So we'll multiply the radius by itself 2 times, or raising it to the power of 2. That's 14 times 14. Then you multiply it by the value of pi. Assuming that our value of pi is 3.143, then we are going to be obtaining the value of 616 square centimeters as our area. I hope you have mastered the introduction to the circle. So what's next now? So in our next videos, we will first look on how to find the length of an arc. We'll move on to find the perimeter of sectors and the perimeter of segments. Then we will move on to talk about the area of triangles on sectors, and then jump on to find the areas of sectors and of segments. And at the very end of the day, we will then get ourselves involved in finding the equation of a circle. Thank you. Let's meet in the next videos.